This slide describes the oil preservation system of the transformer. The non-breathing type, also known as sealed type, are for smaller size transformers of about 1 MVA. The oil is inside a closed system of the transformer tank and has no contact with the outside air. When the transformer size gets larger, the non-breathing design has severe limitations. The free-breathing design will be more practical for larger transformers. In a free-breathing transformer, the oil is in contact with the outside air. This slide shows the construction of a non-breathing transformer. The transformer tank is completely filled with oil. When the transformer is loaded up, the oil gets heated up and will expand. If the oil expansion is not taken into consideration, the oil will leak out through the gasket of the tank cover. This oil expansion is accommodated by the use of cooling fins that also expands with the oil. One disadvantage of this design is the difficulty to sample the oil for DGA analysis, especially after several DGA sampling. This is due to the partial vacuum created inside the transformer. This slide shows the construction of a variant of the non-breathing transformer. In this design, the oil does not completely fill up the transformer tank. A headspace is intentionally created and filled with dry nitrogen gas. The headspace is to accommodate the thermal expansion of the oil as the transformer is loaded up. This slide shows yet another variant of the non-breathing transformer. The headspace is created in the conservator tank. The headspace is to accommodate the thermal expansion of the oil when the transformer is loaded up. There will be a limit to the size of the transformer for such a design. There will be a pressure difference between the outside air and the headspace inside the conservator tank. As the oil volume contracts due to decreased loading, the outside air will have a larger pressure than the inside headspace. This pressure difference can crush the conservator tank. For a larger transformer, this non-breathing design will not be suitable. This slide shows the construction of a breathing type transformer, which is used for the larger size transformer. This design will not create any pressure difference between the headspace inside the conservator tank and the outside air. The headspace is at the same pressure as the outside air. As the oil volume expands or contracts, the headspace will accommodate the oil expansion. A silica gel breather will be used to remove moisture from the outside air. This will prevent the contamination of the oil with moisture from the outside air. This slide shows a variant of the breathing type transformer. The silica gel breather has limitations to remove moisture from the outside air. Once the silica gel is saturated with moisture, it will not prevent further contamination of the oil with moisture. The solution is to install airbag in the headspace of the conservator tank. In this way, the oil will never be in contact with the outside air.